happier, right? So there we go, and I can, of course, go ahead and, looks like it goes down when I put it in ice water, right? I got about, what, minus 2 volts here in it, right? So it looks like it's working pretty good. And then I heat it up, take it out, and I heat it up in my hand. Other than it being slow, it looks like it's behaving itself, right? So it has woke up. Now, in my particular case, I have a 1.5 meg resistor in my feedback. So let's say, what voltage do I expect it to get out of this? Typically, we're going to stop this now. We can look at this, and now I've got a mean here, but I don't really want to look at voltage. I kind of want to look at current, right? So what's my sensitivity going to be? Well, I need this. My sensitivity, if I take I've got what 39.48 microvolts per degree C. 39.48 E minus 6, right? That's voltage per degree C, right? And I have a gain of 1500, I'm going to say, for me, because I have a 1.5 meg ohm resistor. And that gives me if I have 39.58, okay, so we have 39.48 microvolts per degree C, and that's going to equal 59.22 millivolts per degree C. Okay, now I don't really, what do I have? I've got voltage coming in, and I want to calculate degree C, right? So what do I need to do? I need to take the reciprocal of this, 1 over this, and what am I going to get? I'm going to get voltage per, I'm going to get degree C per volt, which is what I want, right? It's the expected degree C. So I take the reciprocal of that, and I'm going to get 16.89. So this is going to lead to 16.89 degrees C per volt. So if I get 1 volt, I'm going to expect to get 16 degrees C, right? Now I already see I'm going to have a problem with this, but because am I going to be able to get to 100 degrees C? No, I'm going to run out of headroom right before I get to 6 volts, right? I'm going to run out of headroom, but I can play with that, and we'll make it work a little bit longer. So what that does is that gives me a calibration parameter that I can type in here, right? I can run this guy into here, run it into here, complains about it, so I'll delete it. And then what am I going to do? I'm going to multiply my output signal by, I need a constant here, double constant, okay, hook this up, and I want this constant to be 16.89, okay. And what that's going to do is that's going to give me something out here that's roughly degree C, right? It's roughly degree C. Now it's different from room temperature, right? We're going to have to calibrate it for that to get it to be room temperature, but at least it's roughly degree C. And I'm going to go ahead and, because I'm old school, we're going to go ahead and, where did my chart go? There's my chart. I don't like that stop button. I'm going to replace it with Booleans. Come on, Booleans. Stop buttons. Okay. And then I'm going to get a numeric display here, a numeric indicator that I'm going to say is somewhere down here is voltage. And I'm going to put that in just so I know what the voltage is. And then I'm going to copy that over. And I'm going to make this EMPC, right? And then we'll highlight all this and we'll make it real big, this way, right? Because after all, I like big numbers. Right, okay. So we have some temperature per degree C, and I get measured the voltage over here. I just put this little voltage indicator so I know if it exceeds 6 volts, I've got something I have to worry about, and I'll put this degree C thing over here before it goes into the waveform chart. Right in here in almost no time at all. What do I have? I have something I can run on here, right? It says I'm at minus 15 degrees C. When I heat it up, it gets to be something warmer, right? Now, one might ask why it's not going positive for that, but hey, you know, differences in resistors, you'll get a little bit of bias in things, and that's just the way it's going to go. Sometimes we'll calibrate those out. Take my hand off of those, it gets back to where it's colder again. I actually kind of like that, and then if I gotta drive it down there, I'm going to get it to go way cold, right? So, okay. So, looks like something is working here now. Okay, so that's the first part we have. Then we have a working thermocouple system. Now, what else am I going to ask you guys to do? Because I'm a mean and nasty instructor, right? Let's see. The first thing we're going to do is we're going to wire up a thermocouple amplifier circuit. So we're going to wire all 6 resistors and capacitor. I have faith in thermocouple and DAC and power supply. So all kinds of things. I'll get you some resistors.
Okay, thank you.
You don't have resistors?
She's
You got
a
resistors in there.
capacitor.
No, the
Oh,
round
capacitor.
thingy.
Okay, yeah,
Capacitor,
that's okay. Capacitor, we'll get you a capacitor.
Okay, thank you.
Okay, so that. Okay, then we need to construct a program that acquires a signal from the amplifier circuit and displays it on the screen in both digital and Fahrenheit. Okay. Well, Celsius and Fahrenheit, sorry, Celsius and Fahrenheit. I'm already doing that, right? Okay, so you need to write it to a file. Well, you already know how to write it to a file, right? I think you've been writing to a file for what? 4 weeks now, right? So you can make stuff that writes to a file. Okay, now we're going to need to linear calibrate it. Because obviously it's right now going to go to 0 or whatever the drift of the amplifier is. In my case, something negative, right? Because that's just what the resistors will end up being. It's, for whatever reason, it has a little bit of DC bias. Okay, I can live with that. Okay. That's not a real good thing. Well, it's not a bad thing, but it's the thing that, hey, we have to just deal with. So what do we need to do? Calibrate that out. Okay, so how do we calibrate it? Well, we're going to need the 2 terms. We have the slope and the offset. We're going to need to add the offset and then multiply by the slope, just like we did in the thermistor one. All right, so you remember that all, right?
Yes.
See, okay. I noticed that she's gonna, when I actually ask her to demonstrate, she's gonna say she doesn't speak Spanish then, right? And okay, and then we're gonna calibrate that, right? And then you get to go take some pictures of it, okay? Does that sound like a reasonable thing to do? So actually, from the programming standpoint, this one is,
Almost the same as the last one.
well, it's much easier because you don't have the nonlinearities, right? I mean, it's the same as the last one without the interpolation and the curve fitting stuff, right? Because we don't have any, and we don't have to do the division in the signals. We just get one signal, right? So the programming standpoint, this is much easier, right? Because shoot, you just get a signal. All you have to do is multiply it and then do a linear calibration on it. Okay, from the electrical standpoint, it's harder to hook up, right? But hey, that's okay. That's why we're here. We're going to have fun tonight. Okay, so questions, comments, slander, libel. Okay, I guess slander. You're going to have to libel me later, right? Is it libel written, slander spoken?
something like that.
Yes, okay.
I need a proper.
Label you now, slander you later.
Okay, that's, you want another thermocouple.
I want a proper thermocouple.
You want